Hi guys, welcome back. Today we'll go into image processing the absolute basics. Uh, that's we will start off with pixels and see what is a pixel, how pixels you know make up an image, etc. etc. But first, let's go into pixel. What is a pixel? Well, actually, the word pixel comes from two words, picture element, and this is the smallest unit, programmable unit, programmable and storable unit of an image. And what does it contain? Well, a pixel will contain the color, the data, and so how many bits and bytes do we require to store an image? We'll go into that. Now here I've made some notes. So what is a pixel? A pixel, as I've already mentioned, short for picture element, comes from these two words, is the smallest unit of a digital image or display. Each pixel represents a single point, or you can visualize that as a dot on your mobile screen or your computer screen. Now, the number of dots on your computer screens may or may not be the same as the number of pixels, but if you're using your computers or your mobile at the highest resolution, yes, uh, they may be the same as the number of dots on the screen. So, so what is a pixel? So ultimately, we see that yes, it's a picture element. What is this smallest element? What does it store? It stores the color information. Now, in digital imaging or image processing, see, uh, data is stored in bits and bytes. We know that 8 bits equal to 1 byte. Now, 1 bit, 1 bit can store what all values can it store? It can store either a 0 or a 1. Simple. So, if we consider a pixel to be a 1 bit, uh, you know, it can store in only 1 bit, then you can store only two colors. You can either have a 0, which is black, let's say, or a 1, which is white. So you can store a black and white image in 1 bit. Now, in 2 bits, you'll be able to store, sorry, you'll be able to store 2 to the power, that is, okay, where's the power? I can't get the power symbol out here. 2 to the power 2, okay, which is again equal to 4 in 3 bits. So this becomes, 2 to the power 3, 3. So, which is equal to 8, dot, dot, dot. So, 8 bits, so 8 bits, you can store 2 to the power 8, which is equal to, if I'm not mistaken, 256. And the values of this, obviously, now, 8 bits is 1 byte. Okay, 4 bits will actually, it makes a nibble. I don't know whether you guys have heard of that. The nibble is half, if I'm not mistaken, if I remember correctly. Okay. Anyway, eight important thing is 8 bits, which is 1 byte, can store 256, colors. So, so forth and so on. Now, in modern day images, generally, generally, images are stored in each pixel has a red component, a green component, and a blue component. I'll just prove it to you. I'll try and prove it to you through the software, the image editor that we are trying to develop together with everyone else. And anyway, so it contains modern images. It contains a red component, a green component, and a blue component. Now, for each of these, 8 bits are given. So that is 1 byte. 8 for red, 8 bits, and 8. So this is 1 byte. Sorry, this is 1 byte, 1 byte, and this is 1 byte. So this gives us, so the degree of red, the degree of green, and the degree of blue will give the color, will define the color of that particular pixel. And how much storage is required? Actually, the total storage will depend on a lot of things, the size of the image and all that. But so far as pixels are concerned, obviously, it will require at the very minimum for each pixel, it will require 24 bits. Okay, 8 into 3, 24 bits. That is 3 bytes. 24 bits, 3 bytes. Now, this is also known as the depth of the image. We will mostly be dealing with red, green, and blue. There is a fourth factor out here, which we will see later. Alpha. Now, if there is this alpha, now what is this alpha channel? Alpha is nothing but it stores the degree of opaqueness or transparency. Just the opposite actually. So it again varies from 0 to 256. Remember, 1 byte you can store 256 colors. 0 to 256, I said that's wrong. It's 0 to 255. That's the values that you can store from 0 to 255. Okay, the number of values is obviously, the number is 256. Now, we will now go and so most current images we deal with are either 24 bits, the depth, or 32 bits. But if we have the alpha also, so either it will be 24 bits or it will be 32 bits. You can have monochrome images stored in much lesser bits. You can have grayscale, etc., 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 etc. We'll go into all that. Okay. Now, the next part, we will start off by proving that yes, indeed, modern images with 3 channels minimum have got a red component, green component, and a blue component, and we'll see what these components are. Okay. Thank you so much. Until the next part.